All right, so I want to talk about influential points and how they change the slope, the y-intercept, and r. So this allows me to just kind of like throw some dots on here. Maybe that's more than I want. Hold on. And then I can draw the least squares line, or little dot draw for me. Thought it would. Why is it? Okay. So let's start with residuals. We're gonna do like a sheet on that in a second. But residual is just the distance between this red dot is like an actual data point that was found in whatever we're doing. And then this blue line is what we predict was going to happen. So the residual is the difference between them. So I can put draw. You guys see that okay with those little lines there? So that little red line, I guess, represents the residual. So if it's above the line, if the point is above what we expected, this would be like in your example, like you wear a bigger shoe size than we predicted. If we're above the line, the residual is positive. If we're below the line, the residual is negative. We'll do more with that on a sheet in a second. And then I want to show you so what's called influential points and talk about how things would change. So write this down. Influential points are endpoints. Endpoints are influential points. Oh, that was your one shot. Endpoints are influential points. Endpoints are influential points. Should I write that? Yes. So what I'm getting at there, and I'm talking about like the slope and the y-intercept and this whole the line. So don't worry about r right now. They're influential in terms of slope. Write that. Endpoints are influential for slope and y-intercept. Endpoints are influential for slope and y-intercept. Influential points are endpoints for slope and y-intercept. Whatever you want. That's a weird sentence. Endpoints are influential points for slope and y-intercept. Or, just kidding. Look at the look on your face, my God. I get it. I was just messing with you. Alright. Okay, so if I put it I wish I had the equation of this line, but it doesn't show it. I couldn't find an applet, it's called an applet, that shows like the actual slope and y-intercept. But I want you to watch what happens. This is if I put a point like where my cursor is up here. Can you see the cursor? That's like an outlier, right? That's way farther away from the line than the other points. What do you think will happen to that blue line? Wait, how would it go down?
Don't worry about it.
Were you just like being smart ass?
No,
Okay, that's fine. I'm gonna go like up here and put a point. And I want to know what will happen to that line. So, is that an endpoint? It's not. So it's not super influential. It will move the line, but it won't move it very much. So this, if I'm guessing, our new line will just look something like that. Like it wouldn't change it very much. If that's our new line, that doesn't matter. Let's do it and see what happens. I'll move a couple around so you can kind of see. Alright, so if I put a dot up there, and I remove it, like, do you see what's happening to the line? Like, not much, right? It's barely moving. If I go way down here, is this an outlier down here? Yeah, it's an outlier in, like, the up and down direction, right? Barely moves the line. But if I put one over here, this is an endpoint. This endpoint, if I put one right there, would it change the line? No, because it's, like, on it, right? If I put one right here, it wouldn't change it. But if I put one, like, over here, I want you to take a second and predict what would happen to the line, what it would look like, and then also like what that means for the slope of the line. So if I put a point here, that's an influential point. So is that line going to tip upward or down? It's going to tip down like toward that. I don't know exactly how much. That's why I have the computer. But if it tilts like that, what happens to our slope? Does our slope go up or down? Our slope went down. And then our y-intercept is like over here. So what happened to our y-intercept? It went up. But those always go opposite from each other. So if you think about like my elbow is the y-axis, like if my slope goes down, maybe my shoulder. If my I think you get what I'm maybe trying to say. If my slope goes down, doesn't the y-intercept have to come up? And if my slope goes up, doesn't my y-intercept have to come down? So let me show you that happens. That's like, watch, my shoulder will move up and down. So if I put a point way over here, like that really made a big difference, right? So the slope went way down because it got flatter, and didn't the y-intercept go like from down here to up there? So if I erase that, like you can see, that makes a humongous difference. Same thing over here. If I put a point right there, what would happen to the line? Nothing. But if I put it up here, slope up or down? Down, y-intercept up. And that makes a pretty big difference, right? Like I know some of your graphs, when you did like the compatibility thing, that's probably too many points. They were just kind of like this. And it's almost just like waiting for a direction. So right now, if I drew the line, it's like nothing. It's like pretty flat. It's not tight. But if I put a point up here, that's going to like really control that line. Because that's influential. So remove it, put it back. Like that makes a big difference, right? Same thing if I put it down here. It's like it really goes toward those endpoints. So that's one thing I want to show you. Does that make sense for slope and y-intercept? Like what happens there? Second thing is what happens to R. So R is our strength, our correlation, right? So the tighter the points are packed together, R is going to be closer to 1 or closer to 0? Closer to 1. And the like more spread out they are, it's closer to 0, right? So what they'll ask you is like if I remove or add a point, what happens to R? So like this point right here, that is right smack in the middle of our line. It is a strong point. If I remove it, am I making the relationship stronger or weaker? Weaker, which means R get closer to 1 or closer to 0. So let's check it. So not very much, right? Because it went from like 0.8096 to 0.8007, but it did go down. Let's put it back. If I remove this point, does that strengthen or weaken the relationship? Strengthen, because you're taking a point away that's like kind of an outlier, right? So R should go up. So it's at 0.8109 right now. Whoa. Did I click something wrong? Because now it's working. Now it's going up. I don't know what happened before. Yeah, does the idea make sense? There's my line. There's the residuals. So let's get those again. Does this have a positive or negative residual? Negative, positive. What's the residual if you're like right on the line? 0. Good. So if I were to add a point right there, strengthen or weaken the relationship? Strengthen, so R should go up. Better work. Yeah, there we go. So it went from 0.55 to 0.67. And then if I remove that, it weakens. Does that make sense with those two things? What's going on there? Questions on anything I'm talking about here? Okay. On everything. On everything. Yeah. Yeah. A little. It's not highly. You guys should take out that graph and try to fill out the front page of this packet. Like really some of the back is probably you want to look at. So this is we're going to use this for something, but this is right now like a good review of stuff we've talked about so far. Let's see where you're at. When I wrote this worksheet, students took the ACT, not the SAT. Did anybody take the ACT? Did you? Did you do better, like, comparative wise on the SAT than the ACT? Was it really? Okay. What about? It felt worse taking it?
Yes, like I didn't feel like I knew anything.
Okay.
But I still did better on that than this.
Okay. That's why I suggest people take both. Like, you're probably gonna do better on one or the other, and then you can kind of put that foot forward. Yeah.
My calculator has like 1% battery in case I'm done.
The battery's right there. There's not. The delivery service is closed right now. Stuck on your calculator.
I did.
I was expecting. I was thinking.
Yeah.
Yeah, I was thinking it was in the range. I know of like 2 or 3 questions. I was pretty there were a lot of them I was confident on. Yeah, with the quiz, all these.
Yeah. Nobody got my equation? Negative 1.06 x plus 117. Oh, I see what I did. Yeah, that's not close at all. Let me try again.
The SAT or ACT score.
Ask it again.
Did you put like the ACT scores as the X?
I didn't have anything in my L. I put it in L2 and L3.
Oh,
But then it defaults and does L1, which is some random crap at L2. Hello? He is. Okay. Matthew, Mr. Gill wants to do it down there. I don't think so. Is that what you guys got? Okay. I wanted to give you guys time to chat on your own, but should we just do it together? That seems like that's going to be helpful. Okay. Okay, so are we good in getting the equation? Do we understand why IQ is X and ACT is Y? There's kind of two ways. When you get a table like this, X is always on the left and Y is always on the right. That's just how the table works. But also, it says I'm trying to use IQ scores to predict ACT scores. So that means IQ scores is my input, and ACTs is my output. So it's like I tell you my IQ, and you try to predict my ACT score. So it's like ordering a pizza. Like I tell you how many toppings, you tell me the price. So interpret the slope. So the slope is 0.16. And this is on that big notepad that you guys took, but we were flying through stuff and there's a lot of info, so I don't expect you to remember it, but you're gonna have to for the test. So remember that slope is y over x. And in this situation, that would be ACT over IQ. Right? And our slope is 0.16. But I want it to be a fraction, so I want something at the bottom, so I'm going to put a 1 there. And then your job is basically to describe this. If IQ increases by 1, remember, it's not like the ACT score will go up by this much. It's like we predict or we expect it to go up by this much. So if IQ increases by 1, we expect ACT to increase. Why did I put increase here and not decrease? It's positive. This one will always be increased because you're always just going to put a positive 1 on the bottom. But the second one, the ACT is increasing because that's a positive number. So we expect ACT to increase by 1.6. Is that alright? So interpret the y-intercepts. So the y-intercept is 4.2. So remember we talked about if you're on the y-axis, what's the x value of every single point on the y-axis? 0. So you can think about this like 0, 4.2. And then we also know it's IQ, ACT. Like really all I need is this sentence. And the sentence not much, right? This is just me kind of guiding you through like how to understand it, how to get there. So what this is saying is if our IQ were 0, we would expect or predict our ACT score to be 4.2. Right? So if IQ were 0, we expect ACT to be 4.2. So then I'm out of room, but I'm not really that worried about this part. It says, tell whether it makes sense in real life. If you had an IQ of 0, you would be dead. So, no, it doesn't. But I'm not that worried about that. So again, this part over here is like, it's like my work or like thinking through it. What I need to see on the test is those. Questions on those two. 100% guaranteed to be on your test. Does that help maybe with like the back of the graph paper too, like what we're trying to get to a little bit there? Alright, find R and interpret it. So for R, I got 0.86. So there is a form of direction and strength, right? So form, I didn't actually look at the graph yet. I should look at the graph to make sure. So if I zoom. Linear, form is linear or not linear? Which one's that? That one's linear. So there's a linear form and then direction. What's direction? What are my options? Positive or negative. In this case, it's positive. I can tell by like looking at the graph is going up, or I can tell because the slope is a positive number. And then 0.86, strong, moderate, weak. Where are we at there? That's strong, right? Strong relationship. But I'm not done because I haven't labeled my graph or labeled my sentence. Like if I just gave this to someone, they'd be like, okay, linear, positive, strong relationship between what? What are you even talking about? So you got to put your variables in there. So between IQ and ACT. But basically, describe the data is basically the same thing. There's a very slight difference, but I'm not worried about it. So those two are the same. Describe the data and find R. Interpret R. Largely the same thing. Which variable is explanatory and which variable is response? So it's actually super nice that the explanatory has the letter X actually in it. The explanatory is your X variable. So explanatory in this case is IQ and response is ACT. I just realized it also has the letter Y, which is maybe not so helpful. It kind of says X, right? Explanatory. And then find and interpret R squared. So R squared was 0.74. And this is one you just gotta, I would say, memorize. So it's on your sheet, so you have to memorize it. I'm not gonna spend a ton of time on it, but the idea is 74% of the variation in the data can be explained by the regression line. I'm not done. I'm just waiting. What have I not done yet that I have to do? I gotta label the graph or put the context in, right? I have to tell the person what I'm talking about. So then you just put on or between IQ and ACT. They are not judging your grammar, so if you put weird sentences, but connect the right words. So just a real quick explanation of what that means. I'm not worried about it at all. Those are not in a perfect line, right? Those dots. So what it means is it's 74% of the way towards a perfect line. So the ACT, your ACT score is influenced by several things. 74% of that influence is your IQ. And then there's 26% left over that's maybe your education that you've had, to your parents' emphasize your school? Did you get some good sleep the night before? Did you eat well? But like 74% of what we're after is in there with just the IQ. That's kind of the main idea. I'm not that worried about that. But I am worried about everything else on this sheet. Everything else on this sheet, pretty much I can guarantee we got your test. So the questions on what'd you do, why'd you do? It'll be multiple choice where you usually where you're like picking out answers that match. But that can get tricky with like slope. So like on a slow multiple choice question, you'll absolutely have an option where it says the opposite. So if ACT increases by 1, we expect IQ. So that's where it gets super helpful to go through this like Y over X and like make sure you realize which one's which. And the same thing with like this one would say if ACT were 0, we expect IQ to be 1.2. Like they'll flip them and make sure you know the difference. And remember, you don't have to memorize it. So even if you had to write it out, it's not too bad. Yeah.
So for like the interpret questions for like slope and stuff, like you would always start it out with every time whatever score increases, and it would always be 1.
For the slope one, it's always going to be like if the X value, whatever that is, increases by 1 every time. Both of them start with X value, right? And we put that on the back of that graph paper. You just don't remember because we did like a billion other things too. But you should have it written down. Doesn't it say like if X value increases by 1, then Y value? I think we wrote that probably.
Yeah, I was making sure it was like that, like for everything.
Totally. Yeah. The graph paper, yeah. So hopefully this is kind of helping you realize like what we did. Because I know that was just like a crap load of notes. Any other questions on the front here? Okay. So that was like review-ish, and then we're gonna do the new stuff. So stay here actually. Stay here. We're gonna find so this is our X. This is our Y. This is our Y hat, or our predicted Y. Those are the same thing. So predicted Y and Y hat are the same. That hat means predicted. So I want to go through every one of those scores and find out what the predicted Y value would have been. Baldwin, can I ask you about? I know why you were down there. I know why you were down there. Can I ask you a question about it? Or would you prefer I do not? Can I ask you a question about it, or would you prefer that I do not? Did you get in trouble? Yeah? Like, what's the trouble? What's your
He's gonna call my parents, and I'm like, go for it. They will not care.
So that's not trouble.
To me, that's
Okay. You didn't get like the whole or something.
like crap. I didn't like it. Like, he was so nasty about it.
Really? I mean, I'm not judging the situation. I was just curious. Okay. So, the predicted values come from the regression equation. So what we're going to do is take every IQ score, plug it into this equation. So let's do the first one together. So I'm going to take 100 and plug it in to this equation. So 0.16 times 100 plus 4.2. And I get 20.2. Over here, I'm going to put the residual. Remember, residual is like residue, like the leftover amount, or like the extra. So that the residual is always going to be the actual Y value minus the predicted Y value. So you walk in, you tell me my IQ is 100. What do you think I'm going to get in the ACT? I'm like 20.2. Guaranteed. You got a 21. So So you did better than I thought. You outperformed the prediction by 0.8. So your residual would be 0.8 because that you did that much better than we predicted you were going to do. You did like extra, beyond, overperformed, overachieved. Would this point, would this 21 be above or below the line that we draw? Above because we did better, right? This is what I predicted. And they got 21. Yeah. So this y hat is the prediction. This is the line. And then this is like what actually happened. This is like what the computer says you're going to do. This is like real life. And then the residual is always going to be in this order. Some people have told me before they do this. So it's actual minus predicted. And they remember it because we're in AP stats. Like in that order. No? No, that's not going to work for you? Okay, fine. So let's do a couple more and then I'll have you fill out the rest of it. So if you walk in and tell me your IQ is 120, I'm going to stick 120 right there. So 0.16 times. And this is where you can do that second enter. Then you can just go back and change the one thing. It doesn't say days and days, but it can help a little bit. So I would have predicted that person to get a 23.4. On average, over the long run, people with an IQ of 120 average out eventually to get a 23.4. Can you get a 23.4 on the ACT? I don't know if you guys even know that. You can't get decimals, but the average can be a decimal, right? That person got a 23. Did they do better or worse than we thought they were going to do? They did worse. So is the residual positive or negative? Negative. Would the point be above or below the line? Below. They like underperformed what the computer thought. So maybe they didn't get enough sleep or who knows. But I'm just doing y minus y hat. So the actual y value minus the predicted y value. Should I do one more? Are you guys good? I'll do one more, and if you're good, just ignore me. So I'm going to take the 150, plug it in for x, and see what we expect to happen if x is 150. I get 28.2 plus. That person got a 32, so just to write down what I'm doing, we do actual minus predicted, so 32 minus 28.2, they did 3.8 better than we expected them to. They would be above the line, they outperformed, and so they have a positive residual. You guys fill the rest of the chart out? We good? Okay, keep going. Wow, the 130 IQ was a disappointment. But the 85 IQ killed. Probably looking at a test like Thursday or Friday next week. We won't have class on Wednesday. The juniors are taking the practice SAT. What are seniors doing? Wednesday. A movie and donuts. I gotta sit and watch people bubble things in for 3 hours, and you're watching a movie and donuts. What movie? I don't know what that is. Is it fiction? It's not like an academic movie though, right? Donuts though. Wait, have your test with it. Not bad.
Are we all doing it? Well, this is-
Are we good on this chart? Are you straight out now though?
Yeah, I'm good now.
Okay.
but I'm still-
Yeah. Okay. Let's just stop there. I don't want to rush the next. Like, I'll be like scrambling to finish the next part. I don't want to do that. So we'll stop there and we'll just pick it up tomorrow. Wait, I know it's gone.